Hello, my name is Aramis Simon, and I am presenting my graphical user interface project for ComTools. So this was the GUI design that I decided to go with. I have there on the top right three boxes to where the user can input their values. The first and second box being the coefficient values for the numerator and denominators respectively, and the third box being the range of the frequency. And below those three boxes I have the analyze button, which would give an output of the other plots and text box that I have on the GUI as well. Starting with the system info, directly parallel to those three boxes that I previously mentioned, that will display relevant information such as the poles of the system, zero, step time, rise time, and percentage overshoot. And on the bottom of this GUI, I have four different plots. The top two are the magnitude and phases of the boat plot that I calculated using the transfer function that will be created once you've inputted your coefficients and range of frequency. And below those two plots, I have the root locus and the step response for the same transfer function. So for this slide and the next two slides, I will be giving examples of my GUI working and producing the correct values and outputs. So this first example is of a system that is asymptotically and BIBO stable, and it has a transfer function of 1 over s squared plus 3s plus 2, with a range of frequency of 0.01 to 100. Now, to see that my GUI has done the calculations correctly, we could take a look at the system info box that gives us our poles and compare that to the root locus plot. And we can see that they have both the correct or the same poles, where we have a dot on -2 and a dot on -1, which is the same as what it was given in the system info. The next example is of a marginally stable system that has a transfer function of 1 over s squared plus 1, and it has a range frequency of 0.001 to 1000. And again, we can take a look at the root locus and the poles information that was given in the system info box, and we can see that has characteristic of a marginally stable system. Both of the roots are on the zero real axis, or both on the imaginary axis only, and that is correspondent to a marginally stable system. So for my last example, this is a system that is both asymptotically and BIBO unstable, and it has a transfer function of 1 over s squared minus s minus 2, and it has a range of frequency of negative 0.001 to 1000. And we can take a look at the step response with it going upwards compared to the stable system where it goes downwards. And we can also take a look at the root lotus, which has a dot on the right hand plane, and whenever a system has a dot on the right hand plane, that means that the system is unstable. And it is also shown in the poles where we have a positive 2, which correlates to the root locus shown. So there were two main difficulties when I was working on this project. The first being how I wanted to present the GUI. There were a couple of designs that I came through. In my report, I mentioned that the first design was where all the plots were on the left-hand side and the system info box being on the bottom right and everything else in the top right corner. But when I started labeling all of the plots, like the Y labels and the X labels and the title of the graphs, all the words started overlapping with each other, and that didn't look very presentable. So I ended up going with the design that I showed you in the beginning, where I had all the plots on the bottom 2/3 of the GUI, the system info box in the top left, and the inputs being on the top right, and the analyze button to start the process of the GUI calculations. The second difficulty that I experienced was probably the largest one, and that was manually calculating the magnitude bow plot and the phase bow plot. I spent quite a while figuring out how to code it correctly to get the values that I would get when I just used the bold function that's provided by MATLAB. I spent again quite a long time on it. I had the many difficulties such as the indexes not being correct or that the sizes weren't matching each other. I did for loops. I did for loops from my first few attempts, but I ended up just sticking with what was in my code, where I just did polyval functions with a JW being its second option, and the transfer function that I calculated before going in the first options, and that some miraculously gave me the values that I needed to plot them, and it seemed to work because they match completely to what I had when I used the bold function. And that is it for my presentation on my GUI project. I hope that this was very clarifying and easy to understand, so that when you use it from your end, you won't be confused about how to use it. Thank you.